This is problem number 1 on exam 1 of module 8 in the book Problem Solving Guide for Electromagnetism and Optics. Problem 1 is a circular wire loop has a current of 2 amps in the clockwise direction and a diameter of 10 centimeters. What is the magnitude of the magnetic field and the direction at the center of the loop? We'll address part B later. Let's get the magnitude and direction of the magnetic field at the center of the loop. First, the direction, using the right-hand rule, putting our thumb in the direction of the conventional current I. Our fingers are pointing into the page all the way around the loop, so the direction is into the page. Now we have to get the magnitude. The equation is mu naught I over 4 pi r times the arc, the angle of the arc theta, and that's one time around, which is 2 pi. So this theta is 2 pi, one complete loop. So now we can plug in 2 pi and all the rest of the numbers. U naught, 4 pi times 10 to the minus 7th newtons per square amp. The current is 2 amps, 4 pi, and we convert the radius, which is 5 centimeters, to meters. Multiply by 2 pi, and we get the magnitude of the magnetic field from the loop is 25.1 microtesla into the page. That's part A. Part B says we have a wire that carries a current of 2 amps, a vertical wire, straight up and down. Where can it be positioned relatively to the center of the loop so that it reduces the magnetic field at the center of the loop to 0? So let's add the vertical wire, but before we do, let's think about whether it's to the right or the left of the center of the arc. If it's over here to the right, the current is going upward. So if we stick our thumb along the upward current and we're to the right of the loop, we get out of the page at the center of the loop. So I think it should be to the right. Yes. On the right of the center of the loop. There it is. Somewhere over here, if we stick our thumb along the current here, it's directly out of the page. The field from the arc is directly into the page. So we're trying to cancel the field right here. Now we have to figure out where to put that wire, where to put that vertical wire. The fields must balance, equal in magnitude, opposite in direction. So the magnetic field at the center of the loop from the straight wire must be 25.1 microtesla out of the page. We can set the magnetic field from the wire and the magnetic field from the arc equal to each other. The wire is double infinite, so there's a 2 here. For a wire, we have mu naught I over 4 pi a, and it happens that the current is the same. That might not always be the case. But here it says in the statement of the problem, the loop current is 2 amps and the wire current is 2 amps, so those I's cancel. The only thing that we're left with is the A, the 2 pi, and the R. So A is R over pi, 5 centimeters over pi, which is 1.9 centimeters. So it's pretty close. It's inside the arc. The radius of the arc is 5 centimeters. So we really should put that wire inside the arc about 1/3 of the way out from the center to the edge. So the answer is the wire should be placed 1.59 centimeters to the right of the center of the loop. That's problem 1.